Can everyone hear me? Can everyone see me? How's everyone doing? We'll check in live here. Let's see. How's everyone doing? We should be live. Can people see me? Oh no! Just checking in on a few things real quick here. Good stuff. We'll start up here in a moment. Can everyone hear me? It looks like the video is a little shaky. Can everyone hear me? So type in the chat if you can hear me well and say hey. Awesome. Good to hear. Let's hope there's enough time on all these questions. Make sure to log in. Everyone should know where the Kahoot code is by now. Just checking in on a few final things here. We should be started up pretty soon. Does anyone have any major questions right now? Anything people are stuck on? What are you guys thinking? It's so quiet. Ask those questions if you got them. We'll get started here pretty soon. If you have questions, feel free to ask them. Where is the code? It is on our webpage. It is on our webpage. The code is on our webpage. Go to the webpage to get the code. We got 33 people in. We'll get started in about 5 minutes. So jump output. I think we got some jump output on this. Nice job. Thanks for telling them where to go, Michael. That's what we want to do. Tell them where to go. Don't put the code in the chat. Whatever. If my mods see codes in the chat, please remove the code. Took me a few minutes too. So I'm like, where is all those codes at? Get everything going ready here. If there's questions, feel free to ask. Interpretations for different means and concepts. Yes, Chrissy, we will do that. We will do that here shortly. That sounds like a good plan to me too. Yes. Let's get started here in about 5, 6, let's do it in 2 minutes here. 2 minutes. Let's get started in 2 minutes. Thanks for the like. Someone's already liked the video. I haven't even done anything yet. I've just been here talking to you guys and gals. So we will do this. Get situated here, get ready to start up the review and answer all those questions. Feel free to ask. Looks like we're streaming all right. Stream quality looks pretty good. Ask those questions if you got them. Remember, this is a review mostly ran by everyone in the chat right now, so you need to be present and, well, you don't need to be here now, but just make sure to give your comments, give your questions, and that will do it. So if you have questions, feel free to ask. If you have questions, feel free to ask at any time. Why is the chi-squared one-sided only? That's a great question. So Chrissy asked, why is the chi-squared one-sided only? It's the way in which we do the test, because we're looking for a chi-squared test statistic as large or larger than. If we think about this, when we do the observed minus expected squared over expected, we're looking at the difference between them, and we're standardizing the difference between the observed minus expected square over expected. That's the top part of the equation. But if the difference was really small, we wouldn't think that difference is odd. So what we're trying to see here is if the difference is larger than we would expect. So it's not a less than or does not equals test, it's a greater than test. We're seeing if the difference between the observed minus the expected is greater than what we would expect. So this difference we're looking at is just a greater than test. So that right there, and we got beta and alpha. Alpha is the type 1 error, beta is the type 2 error. Alpha is simply what you pick it to be. Alpha is just, you pick your type 1 error. It can be 0.05, 0.01, 0.10. You get to pick alpha. Now that does impact beta, and beta is simply your type 2 error, which is impacted by three things: the sample size, the effect size, and your alpha. Those are the three things. Looks like the stream's going pretty well. The text is kind of jittering a tiny bit here. So everything looking good. Let's get started here in about 20 seconds. We will go over some of these Coptics. Why is chi-squared important? What does it tell us? I can't find that anywhere in my notes and was confused. Chi-squared is that x-squared thing. Chi-squared is that x-squared thing. This is all the final chapter. This is all the last chapter. It is the chi-squared test of independence, when you have to get your expecteds, you have to get your cell chi-squareds, all of that. So that is the last chapter, and we'll go over some of that here. Any other last questions? And we'll get started here in about 10 seconds. You guys ready? Is everyone ready? Let's see here. I want you guys to do something. We're going to figure out how long the clap is. I'm going to count. So do this right now. Type clap in the, don't type clap, but type enter. Type clap, and then when you hear me clap, hit enter. So we're going to figure out how long the delay is. So I have clap ready, and when you hear me clap, hit enter. I think we're on like a 6-second delay, which is good. You ready? 1 1000, 2 1000, 3 1000, 4 1000, 5 1000, 6 1000. Yes, we're on a 6-second delay. That's awesome. So that's pretty good for us. Thank you guys very much. We're going to get started. 5-second delay sounds good to me. So let's go ahead and start up the Kahoot. And remember to ask those questions if you got. Look at all those claps in the chat. I like it. Okay, starting the Kahoot. Okay, so the Kahoot is started. And let's go to the first question right here. Which of the following must be met for confidence intervals and for tests? Sorry if my picture's blocking a tiny bit of it. Which of the following must be met for all confidence intervals and tests? Now it looks like there could be multiple right answers here. Which of the following must be met for all confidence intervals and tests? And if you're in my class, I like to do condition 1, condition 2, and then we pause. And these are the ones that you should know, at least for this test, and pretty much state off instantaneously. So these are the conditions that we use all the time, and they'll be met for all confidence intervals and tests. They're not what we first learned when we first did conditions, but these are the conditions we use that you should state for all of them. After these conditions, you should pause and not state more conditions. And we are only on a 4-second delay. I can see the difference between the Kahoot and the timer now. That is amazing. That's so cool. Better internet today than last time. So what is it? The things are the randomness and 10%. Now let's review these conditions. Can anyone tell me, and try to type in the chat, this is a good time for you to practice. Can anyone tell me what the randomness condition means and basically how we check it? Now my Pearson's a little bit, nice job Michael with the answer in the chat, randomness and less than 10%, and how do we check that randomness condition? What should a question basically say for us? If we want to check the randomness condition, what should it say? And it, as Michael said, the question basically tells you. At least on our test, we try to make it as clear as possible. We don't want to trick you. We're not trying to be like, you'll notice on my Pearson questions is sometimes iffy. It's like, we can assume randomness, or maybe it's random. We're going to make it very clear on the test whether or not it's random. We had a question a long time ago that said you went outside of Walmart and talked to people. Now that's not random. We didn't say you talked to random people. We'll usually state on the test question, it's random. A lot of people ask me about this 10% condition. It's a little confusing. Why is it less than 10%? It has to do with finite populations and sampling so much that it creates error within the sample or within our estimates for the truth. Don't worry about the theory beyond it because it's complicated. Basically memorize, for at least for our test today or on Wednesday, that it's the less than 10% condition, which is counterintuitive to a lot of people. But for the way we do the mathematics, we have to sample less than 10%. And the reason is, you don't need to know this reason, but it's because we get error in the calculation. So to stop that, the condition is called less than 10%. So what if I sampled 5,000 UT students? Would we pass the 10% condition if we sampled 5,000 UT students? Go ahead and type in the chat yes or no. Would we pass the 10% condition? And what would you write on the test if the test question said something like, we sampled 5,000 UT students? This is your chance to tell me the answers. Especially, would we pass or fail the 10% condition if we sampled 5,000 UT students at random? 5,000 random UT students. Would we pass or fail the 10% condition? We would definitely, this is your chance to type in the chat. Remember, this is review. It's not just about winning this Kahoot. Would we pass or fail? Michael says there's about 28,000 students at UT. Ooh, we would, wait. Remember, we're sampling 5,000 UT students. 5,000 UT students. Use that information to figure out would we pass or fail. And Sean, nice answer. No, because 5,000 is more than 10%. Yes, and even I would add a little context, Sean. Nice answer. I would say 5,000 is more than 10% of all UT students. So, correct. The other L word is correct too. And Nancy and Chrissy, great answers. So we would fail because 5,000 is more than 10% of all UT students. So answer it that way. Does that make sense? It's sample less than 10%. And these two conditions are very important because for all tests and for all confidence intervals, we will have the randomness condition, take a random sample, and the less than 10% condition, which says we must sample less than 10% of the population. What about if we sampled 5,000 US citizens at random? 5,000 US citizens at random. Go ahead and type an answer in the chat that you would write for that question if it said we sampled 5,000 US citizens at random. So condition 1, random, we meet, we sampled 5,000 random people. It's random. And Ader's right. We would pass the 10% condition, write a full sentence, because usually it says like circle pass fail, but let's give a full sentence and be like, we would pass since 5,000 is less than 10% of the population. And I like Chrissy's answer right here, pass because 5,000 is less than 10% of total US citizen population. Anna, great answer. Chrissy, perfect answer. And always give that context. I think both of you get full credit on the test. Remember, in this instance, 5,000 is less than 10% of all the US population. So let's continue on here to our next Kahoot question. Let's see who's in the lead, those crazy names. Lucky Zebra, well, of course Lucky Zebra's in the lead. So let's check out the next. To make a confidence interval for the true proportion, which is a condition that must be met? Ooh, tricky stuff. So to make a confidence interval for the true proportion, which is a condition that must be met? Now, always slow down and ask yourself this. Am I doing a quantitative or categorical question? Then ask yourself, is it one variable or two variables? So if you're taking notes right now, here's the two notes I would take. Ask yourself, is it categorical or quantitative? And you'll see me do this for each one of these conditions things. Okay, is it categorical or quantitative? Proportions are categorical, like the proportion of people who like Taco Bell, the proportion of people who own a cat. So that is categorical. And then we ask ourselves, is it one variable or two variable? And this is one variable since it's one proportion. And so all proportions use success, failure. And I just gave it away. So if you don't know the answer, I just gave it away. But nearly normal is quantitative. Remember that later. And then the other two on the other side are for categorical data. Pretty good job on the answers right there. Now remember, right here, what do we have? We are using the success failure condition, which states we need at least 10 successes and at least 10 failures. Just type that in the chat right there. It helps you remember things. If you start typing it, you'll start remembering it. The success failure condition is we need at least 10 successes and at least 10 failures. And let's try doing an example of that. So for those typing, what is the success failure condition? What does it mean? Well, we're going to make a confidence interval here. And let's say I went out and I spoke to 200 UT students. If you're listening to me right now and you're writing this down, probably have some notebook paper out and be taking some notes. I would write down n equals 200. Right when I hear I spoke to 200 UT students at random, which passes our random condition, and passes the less than 10% condition, I spoke to 200 UT students at random, and 50 of them said that they study in the library. I want to figure out the true proportion of students who study in the library for finals. So 50 out of the 200, and nice job, Michael, giving a little advice in the chat, 50 out of 200. And so go ahead, see if you can figure out if we pass the success-failure condition when we are talking about making a confidence interval for the true proportion of people who study in the library. We want to make a confidence interval for the true proportion of people who study in the library. And what would you write? We do pass. You are correct, the other L word. What would you write? What would you write to make sure I know? We need at least 10 successes and at least 10 failures. And so what would you write? Remember, I'll recite the question again and see if you can get the answer. So if you're watching this later, try to write your own answers, maybe pause the video, and see if you could write the answer to this close to what I give. So the question states we go to 200 UT students at random, and we ask them, do you study in the library? 50 of them say that they do, and 150 kind of give it away there. Obviously, 150 say that they don't. And we want to see if we just pass the condition for the true proportion of students to make a confidence interval for the true proportion of students who study in the library. So what would be the answer? We're going to pause till someone gets it in the chat. So, yes, Chrissy, you got it. And Chrissy, I like what Chrissy did. Chrissy actually found P hat, and she found Q hat there. And do you know what you found, Chrissy? It's interesting. 50 and 150 are actually x, and then n minus x. So if you notice that, you actually get the proportion of people in my sample who said yes, and the proportion of people in my sample who said no. The np hat is x. If you work the formula x over n equals p hat, and use times both sides by n, you'll get x equals np hat. So interestingly enough, we get to the same result as just doing 50 and 150. But perfect answer, Chrissy. Great job. That's what you should write on the test. So we definitely pass both or at least 10. So that is the third condition for categorical data. And always be watching this chat. They're always giving great answers and great advice. So, and I always think you guys do a great job of teaching each other. So let's continue on to the next question. See who's in the lead. Lucky Zebra. Ooh, it's Space Eagle. That's a cool name. And Glowing Cat. I like all of those. Next. When doing a hypothesis test on the mean, which is a condition that must be met? So now we have the mean. So now we're doing the mean, so I kind of gave it away. See if you have it in your head from reviewing just a moment ago. We have here, remember, we need to ask ourselves, is it categorical or quantitative? Well, the mean, if I'm doing a hypothesis test on the mean, I need to do something that's mean related, like how many hours do people go to school? How much do people weigh? What is your GPA? These are all quantitative questions. So when we do quantitative distributions, we get histograms. And when we get a histogram, the histogram needs to be nearly normal. That's, okay, I've already given these away, but we're just talking through it. Remember, I'll slowly give them away. I'm giving you hint by hint by hint what your brain should go through. First thing, ask yourself, is the condition related to categorical or quantitative? If it's categorical, you're probably doing success failure, and if it's quantitative, you are doing nearly normal. Watch out, we might have a two-variable thing where it's categorical. More on that probably in a moment. So great job. You guys are listening up and definitely catching the answers as I give them. I probably won't give away all answers. Of course, if you know them quicker, you get those bonus points. So everyone always asks me, what is the idea of the nearly normal condition? Well, there's lots of ways to check it. We'll mention them all right here. First of all, you could look at the histogram, and if it looks normal, it's kind of normal. It's not the best way. Don't use that way. Don't write on your test, the histogram looks normal. Don't do that. It's kind of the most basic level way of doing it, though. The second way, which is a better way, is to look at a QQ plot or a normal probability plot. We call it that in this class. Normal probability plots are straight, and we might not put it on the test. It's kind of an older way, and I'll mention why we wouldn't usually use these ways in a moment. And Michael's right. Think about how to visualize it. You can look at that normal probability plot we mentioned all the way back in Chapter 5, or you could do a goodness of fit test to see if a histogram is fit well by a normal distribution. A goodness of fit test sees if the normal distribution is a good fit for it. That's what the goodness of fit test does. But the last way relates to the central limit theorem, which is really the way we like to use for the nearly normal. Because, and this is the reason why I would not use way 1, way 2, or way 3, which I just mentioned, those ways focus in on what we call the parent population. Now, people always look at a skewed distribution, and they say to me, Brian, and Michael will agree with this, they'll say, Brian, there's no way this distribution is normal. That can't be normal. I don't care that you're saying it passes the nearly normal. How is that possible? The central limit theorem states that as n increases, the distribution of the mean gets more normal and tighter by a factor of the square root of n. So the distribution of the mean is what we care about, which this took me a while to grasp. But we're not talking about that distribution you see that is skewed. We're talking about the distribution of the mean, which is more normal and tighter via our knowledge of the central limit theorem. And it's tighter by a factor of the square root of n. That's why we do formulas with like s over square root of n. So let's go to what exactly you should know about this. When it comes down to it, if it looks normal, then the sample size doesn't matter. So if you have a histogram that looks normal and you only have like 15 observations, well, then the distribution of the mean should be normal, because remember, the distribution of the mean will be more normal. So remember, if it's normal, then any sample size is fine because the distribution of the mean will just be more normal. But if it's skewed, then how large should our sample size be? And I'm kind of mentioning the large enough here. If it's skewed, the sample size should be, I bet we're going to see in the chat pretty quickly, they're going to start typing these answers. If it's skewed, the sample size should be at least what? If it's skewed, the sample size should be at least. They're not typing it in the chat. We're waiting for the chat to give the answer. This is the part where you follow along and make sure you know the answer. There we go. Michael, nice job. If it's skewed, it should be at least 25. You are correct. And sometimes in the notes it mentions like 30 or 40 or 50. I like to use 25 and 100 and be consistent. And I just give away the next one. But if it's very skewed, n needs to be larger. If it's very skewed, n needs to be larger. And how large does n need to be if it's very skewed? How large does it need to be if it is very skewed? If it's very skewed, n would need to be 100. You're right. So think about this. The reason we call it, and we've called it in past, the large enough n condition is the more skewed it is, the more skewed the original distribution is, for the distribution of the mean to be normal, the wider n needs to be. So remember, what are we calling it? The more skewed the distribution is, the wider n needs to be. The more skewed the distribution is, n will have to be larger. So when it's normal, n does not matter because it'll be normal anyways, because it just is more normal, the distribution of the mean. And remember, I think it's the hard thing for people to grasp. It's not your distribution we're talking about. Your distribution's still skewed, but if the sample size is at least 25, when we make a distribution of the mean, then it will be normal or nearly normal. It's not like it's exactly normal. That's not what the condition's called. It's basically called the normal enough that we can use the t distribution for it. And that's what it should be called. The normal enough that the t distribution works. So it is nearly normal for quantitative. And if you have two quantitative variables, you have to do it twice. Let's continue on. Great job in the chat. Let's continue on. Lucky Zebra, of course. Great name. You got the best name. Of course, you're going to win. Maybe not. Which of the following must be met for all quantitative data means and test? So, which of the following must be met for all quantitative So, yes, did I repeat a question? Looks like I repeated it. So, if you are given the goodness of fit test and passes, I'll let Chrissy answer right here, and hopefully I haven't made a mistake in my Kahoot as I was editing it today. Chrissy says, to see if we pass the nearly normal condition, is it enough to look at the goodness of fit if we're given it? Yes, Chrissy, you might have seen in test pass. If you pass the goodness of fit, that means the original distribution is normal. So think about this. You've just stated the original distribution is normal, and the distribution of the mean will be more normal. So if the original distribution is normal, then the distribution of the mean is normal. And I would say that. My answer, if I was given a goodness of fit test, would be my goodness of fit test shows my distribution is normal, thus the distribution of the mean will be normal. Because, I'm not going to write more than that. I could go on and on, but if you pass the goodness of fit, yes, that was a review question. Make sure you're listening in. Remember, this is quantitative, so the quantitative is the nearly normal. I was hoping it wasn't a mistake, but it was not. Quantitative is nearly normal, and that's what we have. Does that make sense, Chrissy? If you are given a goodness of fit test and it does pass that, you are good. Because if you pass the goodness of fit on the distribution of the mean will be more normal. So great question there. Thank you, Chrissy. Let's continue on to the next one. And aquatic horse. We lost lucky zebra. Aquatic horse leaps out of the water into the lead. Which of the following must be met for chi-squared test of independence? This is a great job on reviewing your conditions. So you should, by process of elimination, know what the answers are here. Which of the following are met for the chi-squared test of independence? What will it be? So chi-squared test of independence is categorical data. So I've basically given away one of the answers already by saying the chi-squared test of independence is categorical data. It's categorical data. There are two correct answers. Nice job, Michael. Michael's not saying so. She doesn't freak out. She's telling everyone else, don't freak out. There are two correct answers here, and you are correct. So remember, this is to keep everything straight in your head. I think some of the conditions are easier questions if you have them down. I like for everyone to get the easy points first on the test. So we start on the easy level, and then we go to more complicated. So chi-squared, let's kind of, after we see how the question went, pretty good job. We didn't trick too many people. So the chi-squared test of independence, I want you to see if you know it, to write a test question in the chat right now, and that'll show you really know how to do this. And I'll give you 4 test questions while you guys try to think up one. And here's an example, and we're going to make it very short. Let's see if we can predict what animal someone likes by what class level they are at UT. If you notice what I did there, I gave 2 categorical variables. What animal someone likes by what class level they are at UT. And that should tell you how a test question would have to kind of be set up from the start. Let's see if we can see what state someone is from and who they voted for. If you notice, state you're born in is categorical, and who you voted for is categorical. This all relates to the count data condition. By having 2 categorical variables, you will get count data, because simply, and remember, this doesn't mean it's quantitative. Oh, Michael, that would be regression. That's good for a review later. Michael says, how does height explain weight? Or how dependent is height on weight? Those would be 2 quantitative. QQ straight enough. No outliers. That's quantitative. That's regression. No, but good try right there. So, and then you can see, wait a minute, height and weight are quantitative. And looks like the stream's buffering. It buffered for a moment. We're doing all right. We are continuing on. So with this right here, let's see if we can do another one. I want someone, what store someone shops by gender, correct? Favorite animal by animal you've owned. Sure, perfect. So we could ask someone, what's your favorite animal? And we could say, what was the first animal you ever had? Which, a lot of people might be like, dogs are my favorite. And it's like, oh, the first animal you had was a dog. So we might see some sort of dependency, because the chi-squared test of independence would let us see if things are independent or not dependent. Chrissy, exact right answer. And we have something like that on the practice test, where we want to see, I think, the store someone shops at by satisfaction of the store, and I think we're doing like an ABCD satisfaction, like how they would rate their satisfaction on a category, like category of satisfaction or category of items bought, which is Categorical, categorical. Sports you played and video games you played. Perfect, Justin. Perfect answer. That is categorical, categorical, which would do a chi-square test of independence, passes the count data condition, and that is going to make a mosaic plot and a contingency table. All these words right here, mosaic plot, contingency table, chi-squared test of independence, count data, expected cell counts, all of those right there. And look, count data, expected cell count. Those are all very similar, and they're for the chi-squared test of independence. And remember, wait, expecteds go with observed minus expecteds. So trying to link all these topics. Remember, ask those questions if you got it in the chat. Yeah, CC stands for, count. CC, I like that, Michael. All your guys' ways of helping each other remember stuff is excellent. Let's see, next question. Aquatic horse still in the lead. And now, what is p-value for this test? What is p-value for this test? Ooh, we got some output right here. This is output from the chi-squared test of independence. And let's see what the p-value is for the test. These are things you should know instantaneously. If we ask you what the p-value is, you should instantaneously get the p-value and answer it. So I don't want to give it to you yet. I'm going to give hints at 30 seconds and big hints at 15 seconds. So, and we're on an 11-second delay. Let me refresh the stream right here. Try this every once in a while. Refresh the stream. Every once in a while, hit Command R or Control R. Sorry if you can't see the answers. Maybe hit refresh. It looks to be clear once you refresh the stream. Refresh the stream. The answers in the top left to bottom right are going 0.5609, 0.5608, 0.338, 0.0003. So here's the tip, and here's how to remember. The Pearson has your p-value. Oh no, we tricked a lot of people with this one. The Pearson has your p-value. So the Pearson is actually the p-value. I know I made these two very, very close. It's kind of tomato-tomato because in both instances you would fail to reject the null. So remember, when the p-value is high, just let it fly. When the p-value is low, reject the null. And try reloading your page if that helps a lot of people. The stream's only on a 2 or 3 second delay if you reload the page. I reloaded the page and my timer was almost synced. It was about 3 seconds off. So try reloading the page. That might help stream quality, Michael. Feel free to tell me if that helps because I'm interested to know how to make this the best experience for many people watching live. So are there questions on this? When you see the chi-squared test, so what I said, let me repeat it again for you, Cheyenne. The Pearson has your p-value, and when the p-value is low, reject the null. When the p-value is high, just let it fly. And how low does the p-value need to be? Let's say the full saying, and I'm going to type it in the chat right here. If the p-value is lower than alpha, reject the null. If the p-value is higher than alpha, just let it fly. Fail to reject. Alright, 2 seconds. I'm typing good notes in the chart here. Here's the full saying. Here's the full saying in the chat, and here's the mini saying in the chat. If the p-value is lower than alpha, 0.05 by default, reject the null. If the p-value is higher than alpha, just let it fly. So, and fail to reject. So I like to abbreviate it a lot of times to, if the p-value is low, reject the null. If the p-value is high, just let it fly. Just let it be. Don't reject it. Don't reject it. Just let it fly. Does that make sense to everybody? I just repeat it to myself a lot of times. You're going to hear a lot of my sayings today on how I keep things straight in my head. If the p-value is low, reject the null. And type it in the chat. Be very careful. I want you to use the general, not what we think by default. But when we say when the p-value is low, what do we mean by low? When the p-value is low, what do we mean by low? Double check by typing in the chat to see if you know when I say when the p-value is low, what do we mean by low? See if you know it by typing in the chat. What do we mean by low? Less than alpha. That's what we mean. And make sure, remember, alpha is usually 0.05. It's 0.05 by default for pretty much most of statistics, but it can be any value. Alpha can be any value. So what do we mean by p-value low? We mean p-value less than alpha. And when the p-value is low, we reject the null. So lower than the value of alpha. Amanda, nice job. And alpha is usually 0.05 by default, but we can set it to anything. And as Michael says, nice answer, Michael. If we don't see an answer for what alpha is, assume 0.05 if it doesn't say. Would we ever have a question like this on the practice test where we would infer something from a t-statistic by comparing it to z? No, Chrissy, I do that a lot of times. That's my advanced knowledge stuff. Don't worry about that. Great question. I like that. So I might not mention that here, but I like to bring those higher level knowledge parallels sometimes. Great question. I want to mention this also. You'll know things are p-values because you'll often see probabilities. I'm going to say this really quickly. Don't write it down. The p-value is the probability of our results or results from our stream happening by random chance variation given that the null is true. It's my first time ever saying that. So the p-values are probabilities. So when you see here a prob and greater than, it's telling you the probability of the value of your chi-squared or greater than, because it's a probability of greater than your chi-squared. And so it kind of tells you it's a p-value. So what we're to get from that saying I just said is that when we see prob, we should think of a p-value. When we see prob, we should think p-value. Okay, wait, prob, that's p-value. Okay, let's continue on. Next question. And ask those questions in the chat. Aquatic Horse still in the lead. What is your decision regarding the null? Oh, you guys should just obliterate this question. What is your decision regarding the null? Be careful, there's some trick wording here, and there's only two possible right answers. So if you feel adventurous in the chat, please type in the only two possible right answers in the chat. There are only two possible right answers here. So what are the only two possible right answers in the chat? Now, there's only one right answer, but there's two answers you should not pick, and there's two answers you should be picking from, because there's only two decisions we make. Exactly the other L word. We are either going to reject or fail to reject the null. And if we reject the null, we have evidence for the alternative. And I want you to hear me out on this. Fail to reject is the same thing as do not reject. If you do not reject the null, you do not have evidence for the alternative. If you reject the null, you have evidence for your alternative. So just repeat that to yourself. If you reject the null, you have evidence for the alternative. If you do not reject the null, you do not have evidence for the alternative. Let's type that in. If you reject the null, you have evidence for the alternative. If you do not reject the null, you do not have evidence for the alternative. So if you reject the null, you have evidence for the alternative. If you do not reject the null, you do not have evidence for the alternative. And truthfully, I think we should accept I do not reject the null, because that's the same thing as I fail to reject the null. But just remember, I like this right here. When you think about it, it's like, I don't think the null is true. Well, if I don't think the null is true, that means I'm going to believe the alternative to some extent. I haven't proven it. I just have evidence for it because I reject the null. Because if you have evidence for something else, you'd reject what you currently believe. Now, it looks like everyone got it, but remember our saying. When the p-value is low, and this is what you'd look at. To see if you reject the null, you just look at the p-value, and this alpha assumes 0.05, and it would have to have a very, very high alpha. Let me ask this question right here. See if you can answer in the chat. If the question, and now this is pretty much a nonsense question, but the question could state, using an alpha of this, you would not reject the null. Using an alpha of this, you would not reject the null. Someone give me an alpha, which it's going to be a crazy number, which we would never use. But using an alpha of blank, we would not reject the null. And that's not a bad question. Using an alpha of blank, we would not reject the null. And it would maybe say something like, although this is kind of ludicrous and no statistician would ever do this, using an alpha of blank, we would not reject the null. Alpha is a number you can pick, and it's the point at which you reject the null. Nice job, Michael. Michael said 0.60. And remember, alpha is the point at which you reject. So at this point, we have, or excuse me, I should have said, I think I reversed my question, because I keep looking at this and I'm thinking we don't reject. But using an alpha of 0.6, we would reject the null. Sorry if I made that confusing. I think my brain jumped on this question a tiny bit. But using an alpha of 0.6, because remember, when the p-value is lower than alpha, we reject the null. And if you make up an alpha of 0.6, because you can just pick alpha, if you make up an alpha of 0.6, your p-value is lower than alpha. Can everyone see here that this p-value right here is now lower than 0.6? So usually we don't make up crazy alphas. That's kind of crazy because that would mean you would reject the null by random chance 60% of the time, and you would just be concluding the alternative and making, or evidence for the alternative, making probably a lot of type 1 errors. Advanced knowledge for the moment, we'll do that later on. But, and sorry, I think I made a mistake, so please, if you got confused by what I just said, the question should have been, make up an alpha to where we would reject the null. So I think the other L word, your answer might have been correct. Using an alpha of 0.05, you would not reject the null. Using an alpha of 0.10, we would not reject the null. As Michael says, using an alpha of 0.40, we would not reject the null. Using an alpha of 0.60, we would reject the null. And now pause as I say, using an alpha of 0.70, we would reject the null, because all you have to do is look at your p-value and see, is my p-value lower than alpha? So for all those numbers I just said, like if I say using an alpha of 0.01, look at your p-value. This right here is above 0.01, my p-value is high, don't reject the null. So using an alpha of 0.01, I fail to reject the null. Now all of these alphas are pretty, and as the other L word says, if you use an alpha of 0, you'll never reject the null, and you'll just make a bunch of type 2 errors. And so alpha of 0.0 is also kind of ludicrous, because you'll never reject the null, because you can't get a p-value of 0. So that would make it impossible. Nice answer, and you are theoretically correct on that. That is a great thing to know. We probably can't quiz you on that on the test. Would it be problematic for equations? Not so much. You can just come up with whatever alpha you want. It's just how much evidence you require. So if your friend, let's say you have a whimsical friend who's always changing their beliefs. You have a whimsical friend who's always changing their beliefs. Type in the chat right now and give me an alpha value that they would have, just to kind of get this down conceptually. Type in the chat an alpha value that your friend would have if they're just kind of whimsically changing their beliefs. What would be an alpha value they might have if they just whimsically change their beliefs? What would be an alpha value your friend might have if they change their beliefs really quickly and quite often? Oh. Remember, just a moment ago we said an alpha of 0 makes it impossible to reject the null. So the lower the alpha, the harder it is to conclude or have evidence for the alternative. So if your friend changes their beliefs often, it doesn't require much evidence to convince them. And the higher alpha, the less evidence it requires. So alpha is how much evidence we require. Does that make sense to everybody as we talk through this kind of conceptually? That if you put your alpha really high, it's easy to reject the null. But if you put your alpha really low, it makes it harder to reject the null. So I think people might, just conceptually, we're kind of talking about what alpha does. So good stuff right here. We'll continue on to the next one. Ask all those questions in the chat. Anything you type, I will explain or go through. Aquatic horse is stampeding its way to the lead underwater. Say your conclusion out loud. Still, I like these ones right here. So I want you to read off your conclusion to this test. Now, what we have to do is we have to do, and you can probably just do I did it. There's no wrong answer. I hope this isn't the one where I made the mistake and didn't put, probably hit the red one. Oh no. I hope this isn't the one I've messed up. There might be some randomness in who wins. Oh my. So let's take a look at this and try to conclude more from this. Let's work this question. We got a lot of output. So the first thing I need to do is I need to write my null and alternative. So try right now, pause this video or write in the chat, write the null and alternative. And I think I do this later on in this one, but it's really easy to do the null and alternative. Gender, put a word right between here, is independent of breaking a bone. The alternative would be gender is not independent of breaking a bone. If you look, we have count data, or categorical data, which makes count data. A lot of chi-squared stuff right now, and jump output, which you guys and gals wanted. So we have here that gender is independent of breaking a bone. Gender is not independent of breaking a bone is the null and the alternative. So we go down here, we see the p-value. The p-value is low. Since the p-value is low, I reject the null. Since the p-value is low, I reject the null. I reject that gender is independent of breaking a bone. I have evidence that gender is associated or not independent of breaking a bone. And who's breaking a bone more? It looks like males break the bones more. That's the way the association goes. Yes, all of those were correct answers, and no one said they didn't do it. But follow through as I went through this output. Can you understand this output and understand what everything means? Now, how do we get these degrees of freedom? We might ask this later on. So the degrees of freedom in this output would be obtained from saying, Brian, this is a 2 by 2. Now, if there were totals, don't count the totals. But there's 2 answers to gender for this, and there's 2 answers to breaking a bone. So a 2 by 2 turns into a 1 by 1. The formula for this is rows minus 1 times columns minus 1. But you can just say, since it's a 2 by 2, let's subtract 1 from each and make it 1 times 1. And 1 times 1 is 1. Would it be wrong to word it as gender and whether someone's broken a bone, or independent and gender and whether someone's breaking a bone? That's great, Chrissy. Nice answer right there. That should be 100%. That would be a perfect answer, just worded differently than I said it. The null states that gender is independent of breaking a bone. The alternative states that gender is not independent of breaking a bone. I reject the null that gender is independent of breaking a bone, and I have evidence that gender and breaking a bone are dependent. There's some association. So Michael is probably going to type the conclusion. We'll see. I think Michael will get it right. And Julianne, I'll double check here in just a second. Thank you for typing that conclusion. So I'll see Michael typing in here in a second, and I'll continue on then. If Michael doesn't type it, I'll answer. So we have here the Pearson chi-squared. This is from the sum of all the individual cell chi-squareds, of which there'd be 1, 2, 3, 4 cell chi-squareds. And here's the p-value, which is low. That gender is independent of breaking a bone because the p-value is 0.001. Yeah, I agree with Michael. Looks to me that males are more often breaking a bone. I have evidence that there's an association. So I reject that gender and breaking a bone are independent. I have evidence that gender and breaking a bone are not independent. It looks to me that males break a bone more often. And you could say with a p-value of 0.001, I reject the null. So I reject, and if you look, I've basically stated my null alternative again, but added to it, I reject, I have evidence. Not the default p-value, actually, the default alpha. And alpha is the point at which we reject. So without knowing an alpha, I would say, and I could say, I'll type in the chat, my p-value of 0.0001 is less than alpha of 0.05. And so my p-value of 0.000, and I might have added one extra O, it probably is that small. My p-value of 0.0001 is less than alpha of 0.05, which is the default. And then I could say, thus I reject the null. So that is your default alpha, and alpha is the point at which we reject the null. So when your p-value is less than alpha, you reject the null. Great questions, Ashley. Thank you. Ask any one of those ones you have in the chat, and I will explain to the best of my ability. So let's continue on here. Aquatic horse still in the lead. Golden otter, that's a cool name. Space eagle, excited cheetah, joyful dolphin. What is the null for this test? You guys should know it instantaneously. This is now a review question. Let's see if you got that null right here. Who has this null for us? Let's see if you have the null. And remember, to do the alternative, you just change one word on it. So let's see if you can get the null. I'm going to pause here. We've got such long timers. You know, I never know what these delays are going to be, so I like to make their timers as long as possible just to make sure. We're doing so well today. And let's see what else we can look at in this output. If you look here, what percent of males are breaking bones? It's more than 50%, a little less than 50% of females are breaking bones. You can see here because the yes extends down to right there. And the yes for this extends over to about right here. So this would be harder. Sometimes we ask you to figure out from the graphics. Oh, wow. Answer's already in. So this would be harder, but I'd say about 45% of males have broken, 55. See, it's very easy to make a mistake. Maybe 60%. It's hard to tell. I would take a straight edge. If we do ask questions like that, we like to make it a little more clear on the test. And maybe about 45% of females have broken a bone, where 55% haven't. Does everyone see how I'm reading this graphic? I can look within, and these would be kind of the row percentages for males and females in your contingency table. So the contingency table would give better information on this because I could actually subtract numbers and figure out what's going on right here. And let's see how we did. Great job on reviewing this. Remember, the null is that they're independent, and the null is kind of a statement without it's what you currently believe. And if you ask people who don't know anything about gender and breaking bones, they might say, well, I think gender is independent of breaking a bone. And we have evidence here that gender is not independent of breaking a bone, that men break bones more often. And that doesn't mean that if you're a male, you've broken a bone. It doesn't mean if you're a female that you haven't broken a bone. I'd love to break the trend, but I broke my arm. I was riding my bike with no hands because I thought that was cool. I was wearing a helmet because that is cool. And so right here, I have broken a bone. And but my sister's also broken a bone. And I don't know if my brother has broken a bone. I actually don't know. I don't think my brother has. So he's in one of the lucky group down here. These are the lucky groups for either one. So remember what kind of value you're answering. Are they P or mu? Michael gives some great advice, which we'll definitely get to. When you do, Michael, be careful. You've got hats on your P's. If you're testing proportions, there'll be no hats, because right now your null alternative in the chat, which this is for another chapter, but I'll mention it, your null alternatives say, the null states that the sample proportion is equal to 0.05, and the alternative states that the sample proportion is not equal to 0.05. So if you were to test the value of 0.05 for a proportion, you would put P there, which would state the null says that the true proportion equals 0.05, and the alternative states that the true proportion does not equal 0.05. I was wrestling to try to make a YouTube video and broke my hand? That's crazy. That is crazy. I have no idea how that happened. That's insane. So, good questions in the chat. And let's continue on. Is Aquatic Horse still in the lead? Space Eagle, no! We tricked Aquatic Horse! Space Eagle is tied with Golden Otter. It looks like they're on a perfect streak here. Nice job. Here we go. What is the alternative? Okay, we should get these. And did I ask the same one? Oh, I'm making it too easy. It's going to get harder here in a second. Nice job. Michael typed another null and alternative in the chat, just making sure, practicing the proportions. Let's answer this one quickly. Gender is not independent of breaking a bone. It should be that triangle. Sorry, I made that way too easy. It's just a review right now. You should know gender is independent of breaking a bone. Gender is not independent of breaking a bone. And when you teach things, you have to go over it usually 3 or 4 times. That's why I do things like this in the review. You have to reinforce it. You don't just learn something once. If I hit every topic in this review and just did them one time, you'd be like, I can't remember everything. But we hit a lot of the main topics here that I want to make sure you know. So we're covering some big spots right here. I obviously can't review everything we've talked about in 90 minutes or close to 2 hours. So remember, gender is independent of breaking a bone. Gender is not independent of breaking a bone. Pretty much the easiest way of doing it. And earlier, some people gave some great ways of doing it. There's additional ways. Let's continue on to this next question. Space Eagle still in the lead. Remember, there are prizes at the end of this if you win. Find the missing value. I love these questions. I bet I have on here some contingency tables. You bet. So we have a missing value right here. Now, there's a lot of ways to find this. And we're going to review 2 ways to find this. Now, this we need to look, and this is an expected. These are counts, which are the values you actually observe. So this 163, this 258, 128, and 221 are the actual numbers. These are the row totals. These are the column totals. These are the grand totals. These are the expected values. We'll get to that in a moment. And these are the cell chi-squareds. The cell chi-squareds. So with each of these values right here, let's go ahead and try to figure out what we need. We need the expected value for yes, female. So do this on your test. Circle this number, circle this number. It's the row total, column total, do a divide by, grand total. Row total times column total over grand total. We've just written out the equation for the expected. So row total times column total over grand total. And so when you do this formula, you should get, all these answers are so close. I hope I didn't put a wrong answer in there. Row total times column total over grand total is expected cell count. And I know I'm looking for an expected because that's the second number in each of these outputs. These counts are the actual amounts of females who did not break a bone, the actual amounts who did break a bone. This is how many I would expect by random chance, and this is there. And the answer is, nice job. Now, if you find out the answer, for those who found out the answer is 261.895. And actually, I probably could have figured out the answer, yes. I could have told you the answer by just doing something super quick. I wish it'd be cool if this was a multiple choice question on the test. It isn't always. We ask this in many different ways a lot of times. But I want you to think, this number plus this number right here must equal to what? So this is an advanced knowledge thing. I would use the formula first. But then you have an advanced knowledge that all of the expecteds in a row must equal up to the what? All of the expected values in the row, type it in the chat. All of these expected values, if I add to the right, must add up to what? So if I were to do this, what would this number plus this number equal? What do you think? See if you can get it. You can actually solve for it another way here, because row total, exactly right. This number plus this number equals the row total. So you could have actually done it quicker by doing 421 minus 159.105. Now I wouldn't do it instantaneously, because I would use the formula and then I would double check, because if you have a double check, it's literally just like ensuring you're right. And why not have a way of just being like, okay, this number plus this number has to equal that number. And then you could be like, well, this number plus this number has to equal 479. And look, they're both 0.105, 105, and the only one that would add to a whole number right here is 0.895. So that's kind of the way I looked at it. I'm like, okay, 0.105, and then the only number that adds to a whole number is this, because 0.105 plus this is a whole number. All these other ones don't make sense because they don't add to a whole number. So I wouldn't use that last way unless you're using it as a double check. Remember, expected cell count is row total times column total over grand total. So the formula, we'll type it in the chat, and feel free to type the answers in the chat. If you get the answer first and you've already typed it in or already answered, you can put the answers in the chat. One of the biggest things is we're here to learn and review. A lot more people watch the Kahoot after it's done, so if you want to put the answers in the chat, you are welcome to. The formulas and the answers are great. Thank you, Michael, for writing that formula right there. So when people watch this later, they can see it and review it. I know a lot of people have said it really, really helps to have those answers in the chat. And if you get it first, you've already answered, so you got your points, and you're helping everyone else, which is great. And you're reviewing by writing it down. So that is the expected cell count right there. Let's continue on. Space Eagle. We lost our lucky zebra. They're gone. No. Oh, no. Maybe they stopped playing. 3 people in 11 answer streak. Wow. Okay. Find the missing value. I bet you this is a cell chi-squared. I bet you, and it is. It's a cell chi-squared. So with this being a cell chi-squared, how do we find this cell chi-squared? The cell chi-squared, and maybe I'll start writing formulas in the chat too, is observed minus expected. Let's rewrite it here. Observed minus expected quantity squared over expected. Observed minus expected is a cell chi-squared. Cell chi-squared. Observed minus expected squared over expected. So we need to look at this, and there's no observed here. But wait, observed is how many I counted. Oh, okay, that's the observed. 128 is the observed. That's how many I observed. And we have a difference here of basically 4. 4 times 4, it's basically 4. Does everyone see how I can see that? 128 and 132. And you can just look at the difference if you're kind of doing it like I do in my head, because we're going to square this, so it doesn't matter if the difference is positive or negative. I'm just going to square it. 4 times 4 is 16. 16 over 131. Well, that looks to be a little bit more than 1%. And if I had to guess, and I did round up, I would guess the answer is this one right here. Because I know it's going to be 3.895 squared over 131.895. Let's see. Feel free to write in the chat. Nice job for those who got the answer. Great job. Feel free to write it in the chat. If you didn't, maybe I'll write the formulas. I'll start writing these formulas. So this would be 128 over 131.895 squared, and then divided this by 131.895. So this right here is the cell chi-squared. Can anyone with all of this information tell me the Pearson chi-squared test statistic? Can anyone tell me the Pearson chi-squared test statistic? Type in the chat, and let me give you this. Oh, there you can see in the background. That equaled to 0.1150. Tell me the Pearson chi-squared test statistic. What would be the Pearson chi-squared test statistic? If you don't know, you can say, Brian, how do we find that? And nice job, the other L word. It looks like they got it. The Pearson chi-squared test statistic would be the sum of this plus this plus this plus this. You add up all the cell chi-squareds to get the Pearson chi-squared test statistic. So the cell chi-squareds add up to make the chi-squared test statistic. And if you notice, so, don't worry, it looks like they got it right. It might have been a comma, not a decimal. But the Pearson chi-squared test statistic would be 0.0953 plus 0.00579 plus 0.01150, which is the value we found a moment ago, plus 0.0699. The sum of all the cell chi-squareds is the Pearson chi-squared test statistic. We are doing great on time. Let's continue on. Space Eagle still in the lead. What are the degrees of freedom for the T-interval? Ooh, nice and quick and good one right here. And we'll review the output. Oh, you guys should know this instantaneously. What are the degrees of freedom for this T-interval? A little bit of degrees of freedom talk right here. What are the degrees of freedom? So when we do that previous one, remember I said it's a 2 by 2, and the formula for the degrees of freedom would be 1 times 1, so 1 degree of freedom. When we do a T-interval, it's for one sample, one mean, and the degrees of freedom formula is n minus 1. So the answer is 769. N minus 1. Degrees of freedom equals n minus 1 for a one sample T. We can do a one sample T interval or a one sample T test. And I really like it when we can look at some output here. This is a confidence interval. Try pause the video here once I say interpret. A confidence interval for the true mean GPA of UT students. And I've basically given away the answer here. We're trying to figure out the true GPA, or let's say high school GPA. I said true mean GPA of UT students. Okay, let's not throw in any extra wording. See if you can interpret this interval and interpret the interval. And I'm going to write the blank interpretation in the chat. So try writing it now while I'm doing it. Okay, I've got the blank interpretation in the chat. I am blank % confident that the true blank is contained in the interval blank to blank. The second part is the hardest part for people, but I basically gave it away. See if you can get it in the chat. This is your time to practice. Be able to write these out and be able to know which thing you're doing. And look, it says mean. Don't say proportion. Please don't say proportion. If it says interpret the interval, make sure to interpret on the test. We try to make it as clear as possible on this test when we want you to interpret. But this here is a mean, so I'm definitely going to say true mean, not true proportion, and then I have to give the context. Does anyone have it in the chat? Let's see. Remember, let's interpret our interval right here. So I'm waiting for someone in the chat to say it. Try typing it. If you practice in the chat, you're getting really good practice. It takes a lot to write it down, to say it, and so that's my biggest advice for people practicing and trying to study. Write these things down that we're studying right now. If you just watch me and you don't pause the video to make sure you're taking notes and practicing, it just kind of goes, it's harder to remember it. But if you pause the video and write down, I am blank % confident that the true blank is contained in the interval blank to blank, it adds extra memory in your brain. You have to do different things to write out. Nice to have all these answers in the chat. I am 95% confident the true mean of high school GPA is contained in the interval 3.81 to 3.85. I'm 95% confident that the true mean GPA of college students is contained in the interval blank to blank. In the context, any context is good right here. Make sure to do the context on the test, whatever it says. I switched the context a little bit. The test will be specific. If the test question said, I'm going to pretend for Jackson's interpretation, it said, we want to figure out the average high school GPA in America. We went out and talked to 200 high school students, 700 high school students, 770 high school students. So let me repeat that. We want to figure out the true high school GPA of college students in America. So we went out and spoke to 770 random high school students. So as Jackson wrote, I am 95% confident the true mean high school GPA is contained in the interval blank to blank. Yes, and I switched my question a few times, Chrissy, and I hope I didn't make it confusing. Just make sure whatever the question asks for the context is that second part. So I made it towards Jackson interval when I made up the fake question at the end here. So the question would read for Jackson's interval, we want to figure out the true high school GPA of high school students in America. We went out and spoke to 770 random high school students, and Jackson has a perfect interpretation for that right there. So, and then for Michael's interval, we want to figure out the true high school GPA of college students. And just make sure whatever the question asks, you give that middle part interpreting it correctly. Does that make sense, Chrissy? Sometimes I go so quickly and I don't want people to be confused. The test won't be confusing, it'll be exact, and just use its exact interpretation. So I think we are good. No. Okay, let's continue on. What is the missing p-value? I love these questions. We get to do a little bit of math right here for the missing p-value. So what would be the missing p-value right here? We'll see some interesting stuff. True, if you miss the context a little bit, Chrissy, it wouldn't be that many points off. So if you make a tiny mistake on the context, no, we do partial credit all the time. So don't worry too much. A lot of the points on an interval are getting the interval, interpreting the interval, and then if the context is nearly perfect, we're like, okay. If there's a small error, we usually maybe a point, just depends on how big the error is, but definitely we want to show how much did the student understand. So there's a difference between someone who leaves a question blank and someone who just changes a little bit of the context. And even then, if it's so minor that we're like, no big deal. Because if it's like a 4-point question for creating and interpreting the interval, we probably don't want to take off that many points if you were to say a small difference, because it's like, well, they basically got it. So sometimes I'll look at it and be like, just don't take off any points. Give them full credit. So we try to make sure we understand how much you knew. So for this question right here, we're looking at all the p-values, which are probabilities. We'll review what this output shows here in a moment. I think we're comparing GPAs of males and females right here. With this right here, we see the less than p-value is missing. And which one of these would be the less than p-value? And I think I carried it out exactly. So the answer would be, who got it? Nice job, we tricked a few people. So let's make sure we know this. Okay, so the less than, let's look at these p-values. Does everyone see, if you were to shade this side right here, this is where your result is at. Just understanding all this output is going to be one of the key things we'll review right here. This t statistic is your result. And as Chrissy has mentioned, t's are kind of like z's. So if you're like, what is a t? I won't go into the whole story of Gossett here, William Stanley Gossett, I think. His name pops into my head right there. But if you notice, this is about a t-score of -3. Now, we can see the degrees of freedom. It looks complicated, which means we're doing a 2-sample t, at least for our class. These are testing the GPAs of males and females. So let's ask a lot of questions here, but let's first do ours. The less than and the greater than must add up to what? The less than and greater than p-value. Look, if I were to shade below here, and everything above here, which is this value right here, the less than and the greater than must add up to what? I do not know what that is. So the less than and greater than p-value must add up to what? The less than and the greater than p-value must add up to what? This p-value right here and this p-value must add up to what? To 1. And we do see that this kind of adds up to 1. I've done it more decimal place accurate. But we also see that this p-value right here, I don't know why that, there we go. Thank you, Michael. And what about the two-sided test? The two-sided test is always what the smaller test. The two-sided test is always what the smaller test. The two-sided test is always what the smaller test. So you see how this is the two-sided, which would be the area here and the area you can barely see over here. So the two-sided test, which is the does not equals test, this is your does not equals, greater than, and less than. It's always double. That's exactly right. So if you think, just put this in your calculator right here and double it, you will obtain this p-value right here. And then if you round this, you'll get 0.0021, and 0.0021 plus 0.9979 adds up to 1. All you're doing when you do the does not equals is taking your smaller p-value and just adding it to the other side. You can see that in the output. It's really hard to see in here, but here's the shaded to the left, and that little tiny area you can barely see is the doubling of it. So when you double 0.00205, you get 0.0041, so just doubling the p-value. Let's look at the remainder of this output. When you see a difference standardized, you're actually doing a test statistic. What is 48 divided by 16? If you know 48 divided by 16, you'd actually say that's 3, and look, it's negative. Now, I want to point this out about this output. It's one of my favorite things. Right here, if you divide these two numbers, it equals the t-ratio. Try typing this in your calculator, and I'm going to type it into the chat. Negative 0.04729 divided by 0.01642. What does that equal? That equals negative 2.8794. So if you look right here, so those two numbers right there, when we divide the difference by the standard error, we get this. Now, something else. This is something that goes pretty advanced here, but when we do 16 times 2, what is 16 times 2? It's 32. 47 minus 32 is 15. 47 plus 32 is 79. I'm actually making a 95% confidence interval by doing 2 times the standard error. This is a little more advanced here. If you're wondering how I'm solving this output, I know some things. I know that basically the t-statistic for a 95% confidence interval, when it has a lot of degrees of freedom, is basically 2. It's closer to 1.96 because that's the z-score. And if you're like, how do I know all this? Don't worry, it's advanced. And I want to point to things you should know instantaneously. What could you do to get the margin of error? Try typing this in the chat, and I'm not going to let you guys off the hook here, but I want you to type a formula right now to get the margin of error with what you know right here. Type a formula to get the margin of error with what you see in this right here. I want you to get the margin of error with this output. I'm going to type a way people might not do, but I want you to type a formula to get the margin of error. Close. That kind of works. That was kind of how I estimated it. You are correct. So that works right there. Yes, and so, yes, upper minus lower divided by 2. Exactly correct. And I'd put that in parentheses right there, Nancy. I would put upper minus lower divided by 2. Try solving for it right now. Try solving for it and see if you can get it. So we could do upper minus mean, or mean minus lower. These are all formulas right here for the margin of error. See if someone can find it in the chat. It should be close to, it should be 0.03214. 0.03214. See if you get it in the chat. I think that's it. It's close to that. Yeah, I think it's... Oh no, you see I made a math error. That's what happens when I do it in my head. I said 0.03214, but you guys are getting 0.03224, and you are correct as I relook at it. But I was trying to do it in my head. You're doing it by checking your work. And if you can find the margin of error here pretty well, you know what's going on to some extent. Not too much else to see. We reject the null here at 0.05 alpha, and we reject the null here. As t gets larger, p-values get smaller, most of them. The lesser or greater will get smaller, and the does not equals will get smaller. It just depends, because if this one gets smaller, this one's get larger. But obviously, we have evidence here, and if this is GPAs, ooh, my last question, who had the higher GPAs? Who had the higher GPAs from this output? We're testing the mean for male and the mean for female. Who had the higher GPA? Who had the higher GPA? Who had the higher GPA? Females, and that's because the difference is negative. Because if you do 8 minus 10, you'll get a negative number, and I'm just making that up, but it's to show that the second number would be bigger. So this difference I see right here are the differences I observed in the sample means. So I observed a difference in the sample mean for male GPA and female GPA of 0.04729, where females had a slightly higher GPA. This difference I observe is statistically significant and suggests to me that there is a difference. And I'm adding in the chat right now. So I'm adding into the chat the null and the alternative, and pretend, let me add a mu before this. So pretend that this has mu before it. So that is a mu right there, and I want you to see how I've written it. So with what I've written in the chat, I'm writing the null and the alternative for this, and this is very good practice. Let's do the does not equals alternative. So that says mu male minus mu female equals 0. Mu male minus mu female does not equal 0. And what do you notice I just do to write my null and alternative for this? All I do is put a mu and a mu here and set it equal to 0. When you see this output, you know you've got two means. You've got the mean for male, the mean for females, and just write mu male minus mu female equals 0. And if I'm going to use this p-value here, which is my two-sided does not equals alternative, then I would have evidence for the true mean for male minus the true mean for female is not equal to 0. So if we're asked to interpret the difference, what would be the best way to interpret it? Right here, the difference between the sample mean of male minus the sample mean of female was 0.04729. I could say negative. And the negative implies that the sample mean for females was higher by 0.04729. So the negative difference of 0.04729 implies that females in the sample had a slightly higher GPA by this amount. Does that make sense? And remember, this is from the sample, and the sample leads us to the conclusion that females do on average have a slightly higher GPA. So any other questions? Remember, this difference right here is for the sample, and then we use the sample to make a test. And remember how to write your null and alternative. Mu male minus mu female equals 0. And if it says, is there a difference? Mu male minus mu female not equal to 0. Great question, Chrissy. Did that help out? Feel free to say you got it or have more questions, and I'll continue on. I think we have just enough time. We're going to be perfect timing because I have to be somewhere close to noon. We look to be good, and let's continue on. Next question. Find the missing p-value. So this one should be pretty quick and pretty easy. You just saw it a second ago. Remember, this p-value right here will be what? You should know that instantaneously. You should see this output. This is the repetition of the review. When you see that p-value, you should be like, I know it. That p-value up here might be in your head still, but that p-value should be something. It should be, double the smallest. Because all we're going to do is take the smaller p-value and double it to get the does not equals alternative. So that's all we have to do to get that p-value. Nice and quick, nice and easy. Do we have that p-value? Double the smallest. The does not equals is double the smallest. Now, you don't know which one's smaller because if we landed over here, the greater than would be smaller. If you land over here, the less than will be smaller. So, nice job. Great job. We lost a bunch of our Kahooters. No! Let's continue on. I think you guys got that one. Space Eagle in the lead. What is the missing T ratio? Did I put the same question here? Hopefully I changed the question. I did change the question. This is a review question now because I've told you how to do it. And I think I know if you should be able to get the answer really quick because I made these numbers super nice. Don't put it in your calculator. See if you see it. See if you get it. And if you don't see it right away, put it in your calculator. But this one right here with the answers that exist, you should be able to that's the answer. I see it. So you should know the answer pretty quickly for this one. You should know the answer pretty quickly. And then see in the chat if you can find the margin of error for that interval. I'm solving the margin of error right now, trying to do it in my head. You guys can tell me if I'm wrong, but I'm adding, I think I've got it. 5. I think it's the margin of error. I think it's the margin of error for that interval. So the T ratio is the difference standardized. The T ratio is the difference standardized. So all we have to do, once again, is take this difference right here and divide it by the standard error. This, on your formula sheet, is y bar 1 minus y bar 2. That is what that is on your formula sheet, y bar 1 minus y bar 2. This on your formula sheet is the square root s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. To repeat, this is y bar 1 minus y bar 2 on your formula sheet, because that's the difference, and this is the standard error of the difference, square root s sub 1 squared over n sub 1 plus n s sub 2 squared over n sub 2. Okay, so great job. If you notice, what did I basically do? I made this right here a ratio of what? Look, 0.23, 0.023. Basically, you could times this by what and get this answer? You could times it by 10. And wait, it's negative. Negative 10. It's like times this by 10 and negative. And that was the answer right here. So I tried to make this one kind of a one. You could see and guess it. Maybe someone saw that, maybe they didn't. But all you have to do to get the t ratio is divide these two numbers. Technically, we could blank out any of these answers, and then you would have to algebra them. So we could blank this, and then it would be x over this equals this number, if we gave you that number. So this just difference over standard error equals t, and that's it right there. So great job. We've been reviewing that a lot. Oh, good job. Good job. People got that. Space Eagle's still in the lead. I'm wondering who Space Eagle is and Golden Otter. So let's continue on. What is the missing value of the difference? I really love this output right here. Oh, you guys just saw it a second ago. But let's type in the formula, and I guess would the formula be? I'm trying to backwork this now. Oh, but what you should do, it should be to backwork it. You guys will probably get this. It would be this right here. That would be the formula right there to get it if you didn't have it, because it's basically x over n. This is not x and n. It's just like this over this equals this. So if we're missing this right here, you would times both sides by it. Does everyone see I'm doing this value over this value equals this? And this is kind of making sure you're reviewing and staying with your knowledge. Once again, I want to make sure you can read this output and know what it means. This value we're seeing right here is the difference we observe between males and females. And we've already seen that the difference, which is this difference right here, there's the answer. Since the difference is negative, females had a larger mean in the sample by that amount. Nice job. You guys are getting it. We're going to know our output by the end of this. We're going to know a few other key topics. We're going to know the output. If you have questions in the chat, feel free to ask. I want to make sure you guys are following and paying attention, knowing what's going on. Let's continue on to the next one here. We're doing great on time. What is the null hypothesis for this test? Oh, I think I've already given it away. I've given these things away. The null always has the what sign. And you should be saying it in the chat. That gives away that answer. The null always has the what sign. The null always has the what sign. These are the questions when you get to it on the test. I want you to feel confident in your answers. I want you to know it instantaneously. Yeah, you guys know it instantaneously now. You guys are listening. All you do is put a mu here minus mu female, and then equals 0. That is the way to do this null and alternative. We can, and someone asked, it was a great question on the last review, we can test values other than 0, but just for our class right now, we're always going to test 0. Like, is there a difference? Well, the null would be there's no difference, which means the difference is equal to 0. So mu male minus mu female equals 0, and then the alternative is, if we want to see if there's a difference, mu male minus mu female not equal to 0. This right here is your chapter for two independent means. If we test two independent means, we need to see the difference between the means, mu1 minus mu2, and that would just be male and female. Let's continue on. This is a lot of review right here. Let's get to a new question. What is the alternative hypothesis for the two-sided test? You guys got this. And I want to point to something here. When we do our notation in statistical notation, let's slow down and let's think about how we have to understand this. The only thing that changes, I want you to say it in the chat, when you write statistical notation, the only thing that changes when you go to the alternative will be the what? The only thing that changes when you go to the alternative will be the what? The only thing that changes will be the what? Once you write your null, to write your alternative, you just change one thing. It just changes the sign. So I see people do things like this all the time. They write a null like this, and it's in the chat now. The null states that the true proportion of students who, and I better watch, the null states, because I don't want to do it the wrong way, the null states that the true proportion of students who eat Chick-fil-A is 60%. Now, what if we're lagging 8? So hit refresh on it if you like, Michael. That might help. Refreshing, just reload the YouTube thing. Just reload the YouTube. That might help. So the alternative would just change the sign. Once I've written my null, I just change the sign. There's always three parts to the statistical notation. The first part is what we're testing. The true proportion of students who like Chick-fil-A or eat at Chick-fil-A. Then we have a sign for the equal sign for the null. And then the next thing is some value we are testing according to the null. So, and I go over this a lot during the review we did on Friday. I think it was Friday. It's forever ago now, it feels like. And so on the review on Friday, I really went over the nulls and the alternatives. But if we were to do the same sort of thing, and we were to test a null where we said the true mean, and this is a U, not a mu, but it's best I can do in short notice, the true mean age of a UT student is equal to 20, then the alternative could be something like the true mean age of a UT student is greater than 20. And I want everyone to see how quickly I can just change my null and alternative, or my null to an alternative. The only thing I'm changing is the sign. I see a lot of tests, because I help grading the final usually, I see a lot of tests where people change it to a y bar or a p hat. You only change the sign. And the null always has the equal sign when we write in statistical notation. So make sure you write down a note for yourself now that the null has the equal sign, and that's the only thing that changes when you write your alternative. And go back through and make sure to write each null and alternative correctly with either p, mu, let me write them in the chat right here, p mu, or mu1 minus mu2. So right here, those are the three things you'd put at the start of it. P, mu, mu1, mu2. And then values on the other side would correspond the following way. And I'm typing them in the chat so you can see. Do you put subscript? You could, technically, you could. The one where you really want to put subscripts are for the mu1 and mu2, because I think it was too much on the previous questions. I think it just looked weird maybe. But generally speaking, I would probably put mu male minus mu female. I would definitely write, for the problems we've been doing, mu male minus mu female. So let's write, the null states that mu male minus mu female. And probably should have put subscript on mine. Sorry about it. I think I was just thinking general notation, because you just replace it for this one. Great question, Chrissy. And if you notice in the chat, I have the 3 different chapters. We can test a proportion, we can test a mean, or we can test the difference between the means. And that's when I said P mu, or mu1 minus mu2. And you see some mu's in the video right now. That's how a mu looks. It's got a little extra tail. And then proportions are values between 0 and 1. Means can be any value. And then usually when we test the difference, we test a difference of 0. And that should explain right there. The only other time we've been doing nulls and alternatives is for the chi-squared test of independence, and that's when we write it out as a sentence. So make sure you know the 4 ways, but in the chat, know the 4 ways to write your null and alternative. Know the 4 ways for each chapter. Proportions, means, difference between the means, and chi-squared test of independence. Those are the 4 ways we've done nulls and alternatives. Okay, let's continue on. Ask those questions in the chat if you got them. Thank you, Chrissy, so much for all your questions. I love it when these are so interpret the difference. Oh, we've already done this. You guys you guys did so great. Okay, so this is review again now. We'll get to some different stuff. I know we got some type 1, type 2 error coming up here in a moment. See if you can interpret the difference right here. You should definitely know this by now. Remember, it's male minus female, and the difference is negative. That means the second one is bigger. So remember the for female proportion? What? Proportion? No, this is means. So there's only 2 right answers with means. The mean for females is that much higher. We should have that right here. And ask those questions in the chat. Lots of output. Great job. Just remember, and we've been going over this a lot, that if the difference is negative, that means the second one is bigger. I think we lost a lot of players, Michael, too. We did. I don't know what happened. Maybe they had another review or something like that. I might try to do another thing live on YouTube. We'll see how time goes, but who knows? We might be doing more this week, so we'll try. But also, this video is watched by a lot of people later on, so I wanted to do it early so people could use this video in their review, and I want to give as many review topics. Oh no, I'm sorry. The reviews from Friday are recorded, and they are in the playlist. If anyone wants to put the playlist link in here, the playlist for Exam 3, which is on the front of the channel, that should be available. Story time, what is the type 1 error? Oh gosh, please tell me I don't. Okay. So you're walking through the woods and you see what looks to be a snake. No, but think, if you're walking through the woods, you're probably going to see a lot of sticks to start. It's probably a lot of sticks everywhere, just sticks and twigs and everything. I agree with Mariah. So it's usually sticks in the woods. So what would be your null? Your null is probably, and we got to watch out because this is going to control it. People have already answered. So the null is stick, and you need evidence that it's a snake. Oh, we're going to have to slow down. So the null is that it's a stick, and you need evidence that it's a snake. So the null, when you're walking through the woods, just do you walk through the woods? Oh, I love that, Michael. Nice answer. Um, so the null is that it's a stick, and you need evidence that it's a snake, because you don't walk through the woods and think that everything's a snake unless you have evidence it's a stick. You walk through the woods and think most things are sticks that you see until you have evidence it's a snake. And think about what would be evidence. It moves. But wait, the wind could make a stick move. So if it moves, it doesn't mean it's a snake. It makes a noise, but sticks can also make noises. Maybe it fell, or like, I don't know, maybe an animal pushed through it, like a snake. But what if you saw it open its mouth? Oh, sticks don't have mouths. So that's okay. Okay, at that point we should definitely reject the null. But what would a type 1 error be? Okay, so I want to see how many people get this without me helping, and I think we only have one more person to answer. Oh, okay, let's give it to them. Let's give them big help. In a type 1, the null is true. In a type 1, the null is true. Look at that null and say to yourself, it is true that it is a stick. But I'm going to reject the null, and I'm going to say I have evidence it's a snake. Wow, a lot of people got this. I should change my questions. Maybe they saw my last review. The null is true, but you reject it. Michael worded it perfectly. And the other L word's correct. We often call it a false positive. Watch out, because false positive means we reject the null when we shouldn't. So if I had reversed what the things were, if I'm going to say I'm a very cautious person, I think everything's a snake until I think it's a stick, I can reverse what the null alternative are. But you are correct. And let's review, and we're going to go very slowly here. Let's try this in the chat. You ready? I want you guys to tell me what would be the type 1 error, and we'll do some of my classic stuff here. The null is that someone is not cheating. The alternative is that they are cheating, and we're going to practice. What would be a type 1 error with these nulls and these alternatives? Look at the chat. In a type 1 error, the null is true. This, if you see, this is a 1. I'm holding up a 1, and then I'm making a T from it. In a type 1 error, the null is true. Now I want you to look at it right there, and I want you to say, the null is true. It is true that they are not cheating. That is what is true. They are not cheating. But you're going to make an error and reject that and say that they are cheating. You say someone is cheating when they actually did not cheat. Someone is not cheating, but you say that they are. Correct. So we say that they are cheating. They are actually not cheating, and we say that they are. And then, so if the null is true in type 1, then is the alternative hypothesis false? That is correct, Cameron. Cameron, you are correct. In a type 1, the null is true, and the alternative is false. But be careful. I don't want to say that. Cameron, you are very correct, but I just want to make sure that, because in a type 2, see how there's a 2 right here? In a type 2, I like to save the F's for that. Because in a type 2, the null is what? In a type 2, the null is, and you should see an F right here, the null is false, and we fail to reject it. So I just repeat to myself, in a type 1, the null is true. In a type 1, the null is true, and we reject it. In a type 2, the null is false, and we fail to reject it. I got a 0 on a spelling test in 3rd grade due to a type 1 error then. There we go right there. And we can all say we know what happened. Sorry, the other L word. It seems you were not cheating, but they rejected that because the truth was you were not cheating, but they rejected it, and they said you had evidence you were cheating. Okay, so let's try this one. Let's try a tougher one. Let's say the null is, okay. Okay, so the null is don't buy the stocks. Okay, so your friend says to you that they can make you millions of dollars, and you say, well, I need evidence for that. I'm just not give you all my money. You've got, you've been saving your whole life. You're in your 50s. You got $100,000 in the bank, which is probably not enough to retire on, but good for you. You've got a lot of money in the bank. You paid off all your debts, and your friend says, I can turn this into $1 million. I'm a stock expert. Yeah, not quite pyramid scheme, but they're like, I'm the best at stocks, and you'd probably want some evidence of that. You'd be like, okay, I need to see how you've been doing. I need to, maybe your evidence is you've known your friend for a really long time. But if a random person said, give me your money, I'm going to put it into stocks, you'd be like, well, I'm not going to give you my money. So your null is to usually not give people your money to buy stocks with it. So what would be a type 2 error in this instance? Explain to me the type 2 error and its consequences. Explain to me the type 2 error and its consequences. Explain to me a type 2 error and its consequences. In a type 2, repeat it to yourself. In a type 2, the null is false. And we fail to reject it. So I have to say to myself, it is false that I should not buy these stocks. But I'm going to fail to reject that, so I'm going to not buy the stocks. And then when you make an error, you always make the wrong choice. Let's see who types in the chat. But remember what I'm doing. Every time I say, in a type 2, the null is false, and I fail to reject it, I have to look at that null, look at it, and say, it is false that I should not buy these stocks. But I'm going to fail to reject that. Oh, Michael, no. No, wait, oh, wait, yeah, correct. Michael, wow, it's so much. Correct, Michael, you are correct. Sorry, Michael, I jumped to the conclusion. Michael is correct. In a... Oh, sorry, Mary. In a type 2, the null is false. So, correct, Chris, you are correct. So the null is false, and I fail to reject it. Oh, no, you were very correct, Michael, and I jumped to the wrong conclusion. It is false that I should not buy these stocks. So I should buy the stocks, but I'm going to not buy the stocks. So you have to be very careful. Remember, in a type 2, the null is false. So that is the wrong choice. The wrong choice is not buying the stocks. And I'm going to make the wrong choice because I'm going to fail to reject the null. So your friend could have made you $1 million, but you decided to not do it. And then the type 1 is just the reverse of that. In a type 1, the null is true. You should not buy the stocks, but you end up buying the stocks with your friend. Does that make sense as we do these examples right here? It's a little tricky, and it's very easy to reverse it. So in a type 2, in this example I've written, you don't buy the stocks when you should have. Because in a type 2, the null is false, and you fail to reject it. So I'm going to still not buy the stocks, because I'm not going to reject the null. Yeah, it turns out your friend is Jeff Bezos. I mean, don't give him... You probably give him some marriage advice, but now he's like, hey, I got this idea. It's called Amazon. I want to make you a 50-50 partner. You don't have to do anything. I just need money. You've got $100,000, and maybe this is like your parents gave you this, and you're like 20 years old. And he's like, just $100,000. I promise you'll be 50-50 the whole way, no matter what. If I get married and get divorced, you still got 50%. Like, you got it. I just need this $100,000 from you. So, Jeff Bezos. So, yeah, man, I had friends tell me to buy Bitcoin. You know, we always count the things, though, like when your friends like, buy Bitcoin, you're like, oh, I didn't buy Bitcoin when it was really cheap. But then you have friends being like, do this, and you don't do it, and it's, yeah. Okay, last few questions here. I hope the video hasn't paused out. I'm seeing a pause. Let's continue on. Let me try reloading. Uh-oh. My video might have frozen. My computer might have crashed. We might be going blind here, everyone. I think my computer crashed, but that's not the computer I'm streaming from. So at this point, I might not be seeing your chats, so I'm going to try to reboot the computer here while we do this, because I think my main computer crashed, which is really odd. Let's go to the next question. What is the type 2 error? Remember, the null is that it... Oh, wait, there's a different story time. Oh no, I got to remember this story. So we have a tree, and we need evidence to chop down the tree. Oh, I hope I don't kill some people's answers here. But the null would be the tree is healthy. The alternative is chop down the tree. So I want you, while I have this 100 seconds here, and hopefully we got 2 answers in so people can still hear me, type in the chat. The null is that the tree is healthy. The alternative is chop down the tree. And if I have reversed this type 1 and type 2 error, I have destroyed some people's answers. The null is that the tree is healthy. And the alternative, which you would have evidence needed for, is to chop down the tree. So I'm going to reboot the computer here. I don't think... Yeah, I'm just looking at the chat through there. So... Okay, I'm rebooting the computer down low. That's always good when the first computer crashes. So, I cannot see anyone chatting. Oh, let's hope we get some right answers here. Okay, so in a type 2, the null is false. So remember, the null is that the tree is healthy. So it is false that the tree is healthy. So if it is false that the tree is healthy, the tree is actually sick. But I'm going to fail to reject the null, which has me believing the tree is healthy. So I'm not going to chop down the tree. Oh no. Oh no. So let's hope I'm right, because if I've reversed my numbers and answers, then I have given everyone a wrong answer. Woo! We got the right answer. We did well. Nice job. I remembered that question. And I'll be back here in just a second. It looks like I've got reboot going. We are back. Did people type it in the chat? Who's my chat people? Thank you so much, Michael, for typing in the chat. And I am back live now. Make sure I'm muted here. Okay, we are good. We are live. And everything's great. Oh, hey, man, that's crazy. Just whole computer crashed. I noticed the chat wasn't moving and I wasn't moving. And I was like, what happened? So we're almost near the end of my time. You guys should have gone right there. It's I make random noises, the other horn. Oh, you are correct. Ric Flair time. Let's continue on. I'm so glad everything. I'm using two computers to stream, so the little MacBook Air is streaming, and then I've got a main screen up here showing me everything. This is kind of the setup we'll be doing. I'm using a Stream Deck to do some of the visuals and stuff, so I won't try it unless I crash it. Here we'll continue on. Last few questions. If someone wanted to write a null using the data, which of these could be used? Ooh. Oh, this is great. This is a great review question. Which of these nulls could be used right here? This is a great review question. We're on a 3-second delay. I love it. So which of these questions could be used to write the null? Which of these? Okay, wait. Here's a big hint right here. I see mean. And when we do a mean, what do we have? When we do the mean, what do we have? When we do the mean, what is the only one we would use? And I remember I was reviewing this earlier in the chat, so this should be a pretty good and quick one. You should be able to figure out which one it is, because which one of these we're doing a mean. Michael put mu equals mean, p equals proportion. You are correct, and you see 3 plausible answers on this screen. The 3 plausible answers are the red one, the blue one, and the green one. Proportions are only between 0 and 1, and nice job, there is only one mean here. So there's only one mean, and the question would say something, we want to see if the average high school GPA is equal to 3.8, or we want to test the value of 3.8, and you have written the proper mean right here, and you followed our formats from earlier. Writing the nulls and the alternatives is a great thing to practice and know how to do pretty quickly, and if you get it down, it'll be some easy questions. Let's continue on. I've got about 10 more minutes. We're close on time. What are 3 things that control the power, not the one used to solve for power? Don't click the one that is what we use for power. What are the 3 things we use to control for power? And then I'll explain them. We'll give away one right here. For those here, I'll give away one at 70 seconds. I don't want to give it away too soon. Let some people get some bonus points on this. So the 3 things used to solve for power. The first one I'll mention is sample size. I want you to pretend that I'm going to play my brother in basketball first. Now, what if you were to watch us play for 1 minute? Well, the null is that my brother's skill level equals my skill level. Oh, it's just guys thinking. So sample size would change. Let's say you watch my brother and I play for 1 minute or 1 hour. In which of those instances would it be easier to tell who's better? When you watch us play for 1 minute or 1 hour? Which of those would it be easier to tell who's better at basketball? You watch us play for 1 minute or 1 hour? It'd be easier to tell who's better when you watch us for 1 hour. Because 1 hour is a larger sample size. And Michael's right, 1 minus b is power. So that is what we use to get power. Beta is a type 2 error. It's not the 3 things that control power. It's what solves for power. It's 1 minus beta. Now, what if I were to play my friend LeBron in basketball? So, LeBron, he's played in the NBA a little bit. He's pretty good. I mean, I don't know. I beat him one time when we were kids. I mean, we did play 1,000 times, and he had been playing basketball all day, and he said he didn't want to play, so I just made the shot, and I told him I beat him. But let's say LeBron and I were to play right now. And so, who would it be easier to tell who's better? When I play my brother in basketball, or when I play my friend LeBron in basketball? When would it be easier to tell who's better? When I play my brother in basketball, or if I play LeBron in basketball? And the answer would be, it'd be much easier to tell who's better when I play LeBron. And the reason is because of effect size. The effect size is the difference between the null and the truth. The null is that I'm equal to LeBron, which is laughable. And so there's a huge difference between LeBron and myself, and you would see that instantaneously. If you watched us play for 1 minute, you'd be like, he's dunked on you 20 times, which I thought was impossible, but he did it. You even tried. You tried, Brian, and he completed the impossible. I only needed to watch this for 2 seconds. I could have blinked my eyes and saw that he was better than you because the effect size is so large. But when the effect size isn't so large, we need to use other things, such as like the sample size. Because if sometimes we have a smaller effect, we need a larger sample to observe it. Now, alpha is the point at which we reject the null. If you reject the null more often, you fail to reject the null less often. So alpha and beta are not complements, but they're inversely related. So when you increase alpha, you decrease beta. And as Michael put in the chat, the formula for power is 1 minus beta. So anything that makes beta smaller makes power bigger. So sample size goes up, power goes up. Alpha goes up, power goes up. Effect size goes up, power goes up. Now, you can't really control the effect size because I can't control how much better LeBron is than me in basketball. It just kind of is what there is. It's the difference between the null and the truth. To think about another effect size, think about if someone was like, I think I'm sick. Well, it'd be really hard to detect that they're sick if they are because it doesn't sound like they're really sick. It sounds like it's a small effect. And maybe they are. It's just going to be harder to detect. You might have to run tons and tons of tests. But what if somebody is like laying on the ground in a pool of their own sweat and you're like, I think they're sick. I think there's something wrong with them. And someone will be like, yeah, yeah. At that point, that's a huge effect and it's tons of evidence. And so at that point, you would probably reject the null, and the effect size is just the true difference. If they really are sick and they have such a high fever and it's so obvious, it would be easier to detect, and thus the test is more powerful, which is the ability to correctly reject the false null. A little bit of a review right there on what sample size, alpha, and effect size are. You can control your sample size if you can get more sample. You can control your alpha at any point, but effect size is just the true difference between the null and the truth. Last few questions. What is the equation for the degrees of freedom in this problem? You guys got this. This is a review question now. Remember, say to me, Brian, that is a blank by blank. The degrees of freedom formula for the degrees of freedom. We're going to end right on time, and I'm going to have to run to campus. So thank everyone very much. I'll be ending here in just a few minutes, and I am available via email. I'm going to type my email in the chat right here. And so I'll be ending pretty quick. Oh, careful. That is a 2x2. You are correct. You might... So that is a 2x2, which makes the degrees of freedom what by what? That is a 2x2, which makes the degrees of freedom the equation 1 by 1. And make sure to solve it. So on the test, it's already in the problem itself. The answer is that there is 1 degree of freedom, and you can see it in the problem. It's a 2x2. There are 2 answers to each question. Do not count the total columns. Do not count the total columns. And Mary types it out exactly. Thank you, Mary. Rows -1 times columns -1. And I usually do it if I can hold it out my fingers. 2x2 turns into a 1 by 1. And do we have a joke question or a real one last? Last question. Interpret the interval in context of the problem. I'm an interpreter. Are you ready? So I am 95% confident. The true mean high school GPA is contained in the interval blank to blank. So I'm going to go up here and I am going to grab it. It might be off the screen. It looks like it's off the screen. I have to retype it. Try doing it yourself. And this is the mean high school GPA. I am blank percent confident that the true blank is contained in the interval blank to blank. Did one person say, oh no, that wasn't, I did it, that wasn't. Oh, no. If you feel like you lost because of that, come talk to me. I'm so sorry. Is that the one? 3 people. I am so sorry. Let's see who won, and if someone lost the lead because of that, please tell me. I might have to give to one other person who... No, I've got... Did someone feel like they lost because of that? Did someone lose their lead? Oh, well, Space Eagle just obliterated it. If anyone wants to say who is Space Eagle, Golden Otter, or Eager Dragon, and also if you feel like you somehow lost, remember I do have gift cards in my office. Send me if you want and tell me. I think I'm in my office 10 to noon, Tuesday through Thursday. Oh, nice job, Michael. Michael, 3rd place right there. Space Eagle. Wow, Chrissy, nice job. 26. You got 26 out of 20. Yeah, Space Eagle, you just excellent job. Perfect streak. Even me messing it up at the end. Like I'm ready to change that. I am at this. I like it. I like it right there, Cameron. Nice job. So I'm gonna head off. Good seeing everybody. Email me those questions if you got them. We're gonna stop streaming right here. Do I still have the stream thing open? All the answers were the red. Were they all the red? No. I didn't randomize the answers. I am so sorry. Oh no, the other L word figured it out. I didn't mean that. Usually I put when I make this, I forgot to hit randomize when I started it, but I always put the right answer in first, and that way I put 3 trick answers and 1 right answer, and then we have to click which one's the right answer. Oh, that's us. Oh no. Oh no. Well, I'm glad we found that out at the end. Don't use that as your trick. Yeah, sorry about that. Great job, everyone. Email me those questions if you got it. I should have hit randomize questions. I didn't. Oops. But email me, and I might do some more reviews. So hop in. You might see me live on the channel at some point. Bye, everybody. Let's go here to the studio. And we're still live right now, so you're still hearing me talking. And I need to go to so many buttons. Oh, wait. Can I go here? Oh, I think I have to go. For any of my YouTube friends right here, I'm going to the old YouTube studio as I talk through this all right here. What's this? Up. Oh, we're almost there. And stream. We're almost there. End stream. End the stream.